Okay, so quiz 4A, two-part quiz. We're talking about, so in part A, you've got 100 products and projects in R&D, 70% chance of making 100 in profit, 20% chance of making 10, and a 10% chance of making 1. These are all in thousands, but it's easier just to work with these so you don't mess up the zeros. So again, we just want to find basically our weighted average or our expected value. So 0.7 times 100 plus 0.2 times 10 plus 0.1 times 1 gives you your expected value per project of 72.1 thousand. You also need to find your standard deviation per project, which is this holy mess, which is again just comes back to your formula of what the value x minus x bar squared times the probability. So these line up approximately like that. And it's the square root of that. That's why I've got to the power of 0.5 here. It's mathematically equivalent. So you get your standard error per project is $42.68 thousand. So, but what you want to know is what is the odds that all 100 put together are going to make you a profit. So then you need to find your expected value of the sum. So I let s equal to sum. So E sub s is going to be equal to 72.1 times n, so 7210. And then your standard error, you need to convert your standard error. Basically, if you remember that you have sigma squared times n is equal to, this is how you convert your standard error when you're adding a bunch of terms. The sigma jumps out, sigma square root n. So, and since we don't have sigma here, we're using standard error. So we use standard error times the square root of n. So it's 42.68 times the square root of n. N is 100, so square root of n is 10. So 42.68 times 10 gives you your new standard error of 426.8. And then we need to find the odds of it being, the lab in general being profitable. And we know that this lab alone cost 8 million. So 8 million converted to thousands is 8,000. So that would be 8,000K more accurately. And we just need to find this probability. You run your z-score in the usual way. So we get 8,000 minus 7210 over your SE of 426.8. And you'll find that the probability of making a profit is 3.2%. So it's really unlikely. Okay, so continuing quiz 4A, part B, we're trying to figure out what's the chances that the firm will be profitable if they open the second R&D lab. So the second R&D lab is also capable of doing 100 jobs, and it's got a 35% chance that one of those leads to something worth 200,000, 45% chance that it's worth 100,000, and 20% chance that it's worth nothing. So it's the same thing that we did last time, multiplied. So I'm using variable y for the new lab, by the way. Same thing we did last time, weighted average multiplied profit times the percent chance that it happens. You get 105,000, and then your SE of x, again, do the same thing that you did last time in case. So it's SE of y would be equal to y minus y bar squared times the probability, sum those all up, and take the square root. So same thing we did last time. I didn't show out the whole math. But one thing to keep in mind for this entire thing, when you're taking E of y, it's the same thing as quiz 1A question 1. You need to remember that there is also a fixed cost. So per project, you need to subtract out 10,000. So when you do the weighted average, you'll get 115, and then subtract 10, you get 105. And then when you're doing the standard deviation, remember to subtract 10 from the value of each one. So for example, just for the first one, you would take, so the profit is 200 minus 10, which is the cost per product, minus 105 squared times the probability, which is 0.35. So that would be your first term when you're calculating standard error. And then, so anyway, so once you do that, you get this. I brought these over from the last board. This is what we calculated in the first part of the question. Same thing here. We calculated the sum of 100 products, the expected value, and the standard error of 100 products, the expected value. So we don't do anything different for the y. So we just, because there's 100 products or projects, so it's 105 times 100, so that's your expected value. Your standard error, again, sigma square root n. So 26.87 times the square root of 100, which is number of projects, basically multiplied by 10, and you get the standard error of the sum. Now this is where this question gets tricky. You have to add x and y. So your expected value between x and y all together, so between all the products in the original and all the products in the new lab. So you're going to add, these should actually be s of x plus s of y, s of x plus s of y. So then that's why we're adding, do exactly what it says here, 72 the s of x coming from here, and s of y coming from over here. You sum those up. This is how much profit you expect to make. Now this is your standard error formula. This is the monster formula that he put online. But here's the trick with this question. This term talks about covariance between these, but since products in the original lab and the new lab are independent, there's no covariance. This term drops out. So then you just have to do the outside parts. We can ignore the a's. So what you actually, all you end up doing is you get the square root of 628.7 squared plus 426.8 squared. Those values are coming from here and here. Sum those up, you get your standard error is equal to 759.88. So now we have a standard error and an expected value. What are we trying to find? We're trying to find the odds that the whole thing is profitable. Well, remember that we had costs for both labs. The first lab will cost you 8 million. The second lab cost you 9 million. 9 million. But since we're working in thousands right now, so the first lab cost you 8,000 and the second lab cost you 9,000. So we want the probability that it's greater than 17,000. So let's draw our picture. This is 17710. This is 17000. So we're finding this. Basic z-square calculation gives you z is equal to negative 0.93. So that means you've got an 82% chance of making a profit. Although he didn't ask it here, one of the key things that this shows is that you decrease risk when you diversify a little bit.